Let's talk about a mission that sounds like something straight out of science fiction. It all starts with a question so bold that for centuries, people wouldn't have even dared to ask it seriously.
And I'm not talking about just looking at it through a telescope from a safe distance. No, I mean actually making contact. What happens when you decide to send a little piece of human technology and fly it through the fire of our own star? I mean, think about it. For literally all of human history, the sun's been this untouchable, almost godlike thing up in the sky. It's this violent, furious ball of plasma just constantly erupting, a place so incredibly hostile that everything we've ever launched has kept a very safe distance. But then we changed the rules. We decided, you know what? We're done just watching. We decided to get in the game. And that single decision gave birth to the Parker Solar Probe. And that is the absolutely incredible story we're diving into today. All right, so here's our game plan. We'll kick things off with the mission itself, which sounds impossible. Then we'll get into the wild tech that lets it survive, its genius autopilot, and the clever slingshot trick it uses to even get there. We'll cover that historic first touch of the sun. And then, most importantly, we'll talk about why any of this matters to you and me. All right, let's jump in. Section 1. The impossible mission. So back in 2018, we launched this thing, the Parker Solar Probe. And its goal, well, it sounded, and I'm not kidding, like a suicide mission. Fly straight into the sun's outer atmosphere, the corona.
And this is where things get really, really weird. I mean, you think the farther you get from a fire, the cooler it gets, right? Simple logic. But nope, not with the sun. Its surface is only about 5,500 degrees Celsius, but its atmosphere, the corona, where we're sending this probe, it skyrockets to over 1,000,000 degrees. I mean, how on earth could anything possibly survive that?
Well, that brings us right to our next part, cheating 1,000,000 degrees. See, this isn't about building some indestructible tank. This is about being clever. It's about a shield that literally outsmarts death. So let's just state the obvious question here. If this place you're flying to is hot enough to literally melt steel like it's butter, how in the world do you build something that can fly right through the middle of it? The answer is this masterpiece of engineering. It's a heat shield, right? Made of a special carbon composite. And get this, it's only about 11.5 centimeters thick. Now, it's built to handle about 1,400 degrees on the side facing the sun. And you're probably thinking, hang on, isn't that a lot less than 1,000,000? And yeah, you are absolutely right. The real magic here isn't just the material. The trick is all about physics. See, there's a huge difference between temperature and heat. Temperature is how fast particles are moving, but heat is how many of those particles actually hit you and transfer that energy. And space is a near-perfect vacuum. So even though the few particles in the corona are super hot, moving at 1,000,000 degrees, there are just so few of them that not many actually hit the probe. It's like the difference between sticking your hand in a hot oven versus getting hit by a single hot spark. The probe doesn't fight the heat. It uses the emptiness of space to basically dodge it. And the result is just mind-blowing. On the front of that shield, you've got this blazing inferno, right? We're talking 1,400 degrees Celsius. But just inches away, on the other side where all the delicate science stuff is, it's a comfy 30 degrees, room temperature. It's an absolutely perfect little oasis of calm, just inches from hell. Okay, so you've got this amazing shield, but that shield is useless if it's not pointing in exactly the right direction all the time. And that's a whole other can of worms. Which brings us to Section 3, a brain that never sleeps. We're talking about the autopilot that is the only thing keeping this probe alive. I really want you to get this. The margin for error here it's 0. It doesn't exist. If that shield tilts even a tiny, tiny bit and exposes what's behind it to the sun, poof, it's over, instantly. And you can't have a person back on Earth flying it with a joystick, right? It takes minutes for a signal to even get there. By the time we know something was wrong, it would already be toast. So what's the solution? The probe has to think for itself. It has this incredible autonomous brain that is constantly feeling for the sun's position, checking its own angle, even sensing radiation. And every single second, it's making these tiny little corrections in real time to keep that shield perfectly aimed. It's not just a machine, it's a self-sufficient survival expert. Okay, so we figured out how to survive this insane environment. Awesome. But now, how do we even get there? You'd think it would be easy, but it's not. And that leads us to this really cool, really clever solution, the Venus slingshot. Yeah, flying to the sun sounds simple, like just falling downhill. But it's actually one of the hardest things to do in the solar system. Why? Because the Earth, and us, and the probe, we're all hurtling sideways around the sun at a blistering 30 kilometers a second. It's like trying to get to the center of a merry-go-round while it's spinning at full speed. You can't just run straight. You have to kill all that sideways speed first. And getting rid of that speed would take a ridiculous amount of fuel. So the engineers came up with this beautiful, elegant solution. Parker does multiple flybys of the planet Venus, but instead of using its gravity to speed up, like a slingshot, it uses it as a brake. It's a gravity assist in reverse. Each time it swings by Venus, it gives away a little bit of its orbital energy, slowing its sideways motion just enough to let it fall a little bit closer to the sun. It's like taking steps down a cosmic staircase. And all of that, the shield, the brain, the clever braking maneuver, it all leads to this, the climax of the entire mission. Section 5, First Contact. This is the moment where years and years of work finally paid off, when the probe actually arrived. So after launching in 2018, it took 3 long years of this careful dance through the solar system using Venus to slow down. But then, in 2021, the impossible happened. The Parker Solar Probe crossed this critical, invisible line and officially entered the sun's atmosphere. It became the very first thing humanity has ever built to actually touch a star. And the things it found there, just wow. It flew right through these violent rivers of plasma. It actually watched magnetic fields just exploding. For the very first time, we got to see the solar wind being born right at its source. And it found these totally bizarre S-shaped kinks in the magnetic field called switchbacks, where the field just suddenly flips around for a second. We're still trying to figure those out.
So, that all sounds pretty cool, right? But it finally brings us to the big question. Why does any of this matter to you? I mean, this isn't just some abstract science project happening millions of miles away. Figuring out the sun's secrets has a very real impact on our lives, right here on Earth. Look, the sun isn't just a pretty light in the sky. It is the engine that runs our entire world. It controls our climate, sure, but its temper tantrums, its solar storms, can wreak havoc on all the technology we rely on. We're talking GPS, our cell phone signals, even the power grids that light our homes. All of it is vulnerable to what the sun decides to do. And the stakes here they're enormous. A single, really massive solar storm, if it's aimed right at us, has the potential to knock out satellites and fry power grids across the globe. We're talking about something that could effectively shut down modern civilization for a while. So by flying into the source of these storms, Parker's like a lookout in the crow's nest. It's a crucial early warning system, helping us figure out how to predict these things before they hit us. When you step back and think about it, this whole mission is just an incredible testament to human ingenuity. I mean, we sent this fragile piece of technology into a place that nature never, ever intended for it to be. And it didn't just survive, it's working. It is living and working inside the atmosphere of a star. And that just leaves you with one final thought, doesn't it? If we can do this, if we can literally touch the sun, what impossible thing are we going to do next?